Hello and welcome back. We'll finish off section 4.1 learning a little bit about an application of exponentials, which is compound interest. So when you invest money, have some sort of savings account with some interest, quite often it will be compound interest, which means that after some time, the principal that you initially invested or put into the savings account, for instance, will earn some interest. And what ends up happening is, for instance, usually at the end of the year, the interest will be added back to the principal, and then you repeat. The next year, this bigger principal will now earn a little bit of interest. You add the principal back. You add the interest back to the principal, and you start this process over again. Interest that is not compounded, the interest will always just be the same, and it'll be off to the side in a separate account. With compound interest, the interest is always added back to the principal. So if your interest is at a constant rate, you'll be earning more and more interest over time because your principal, the amount that you invested, is also getting bigger and bigger and bigger. So if we assign some names to some things, if P is the principal, the amount that we invest, if R is going to be the interest rate, which is going to be given as a percentage, which can also be written as a decimal, and this is always the interest rate. This is the annual interest rate. So we'll just make it consistent. This is always the interest rate over 1 year. And A, we'll just call A the year's end accumulated value. So this is how much we can have at the end of the year. So A here, if we invest for 1 year, we'll have our principal, and we're going to earn a little bit of interest. Well, how much interest? It'll be some percentage of P. It will be P times R. So it'll be the amount that we invested, and it'll be some percentage of that, added back to the principal. And this is how much we have at the end of the year. However, we can factor a P out, and we can write this as P times 1 plus R. And this is the usual way of writing this. So at the end of the year, the amount that we'll have is going to be the principal times 1 plus the annual rate. Now, if we keep it going for a few years, we can write up a nice little formula. So if we had, if we hadn't invested this at all yet, so at 0 years, we're just going to have our principal. We haven't earned any interest yet. At the end of 1 year, we already saw that our accumulated value is going to be our principal plus a little bit. At the end of 2 years, so we're going to take whatever we had at the end of year 1, which was this value, and it's going to grow a little bit. Well, by how much? By the same amount as far as the rate is concerned. And we'll see that this is just a pattern. We're just going to multiply it by 1 plus the rate squared. If we do this for 3 years, we'll take the amount that we had at the end of year 2, which was this, and we'll multiply it by a little bit more. We'll add a little bit more to it. So we'll have P 1 plus R to the 3rd power. So if we keep doing this for T years, you can see the pattern here, and it will be P times 1 plus R to the T power. So again, here's where some exponents will pop up. So we'll take our initial principal, and we'll multiply it by 1 plus the rate to the Tth power, where we've invested our money for T years. Sometimes we compound the interest more than once a year. So up here, this was just saying, we've earned a little bit of interest, and then at the end of the year, we add that interest back to the principal and start the process over. But sometimes we can do it more than once a year. So for instance, if we do this semi-annually, if interest is compounded semi-annually, this means that it'll be compounded twice a year, meaning every 6 months. The interest will be compounded. It'll be added back to the principal so we can earn a little bit more. If we go quarterly, 4 times a year, that means every 3 months our interest is added back to the principal, or monthly, so 12 times a year, our interest is added back, or even daily, so 365 days a year, not including leap years, which just get confusing. 365 times a year, we will add our interest back to our principal, so we can earn a little bit extra interest on it in the next little period. So every 6 months, every 3 months, every 1 month, every 1 day. These are just various ways that we can earn interest, common ways to earn it. And here, again, if we refer back to P being the principal, R being the annual interest rate, and this is why it's important to talk about the annual interest rate. If we're compounding every 6 months, every 3 months, every 1 month, every 1 day, we have to keep in mind that the annual interest rate is what we're basing this off of, not the 1 day interest rate, for instance. If T is going to be the years invested, and N is how many times a year our principal is going to be, our interest is going to be compounded, we adjust our formula just a little bit. So I won't go through this derivation, but essentially we divide R, the rate, by N. So if we're compounding N times a year, we'll divide our rate by N. But we also need to see how many time periods have we gone through. So it's going to be how many years the interest has been accruing, but also how many periods each year we will be compounding in. So this is P times 1 plus R over N to the T times nth power. Now, we can also compound continuously, which whenever we have something going on continuously and not, say, discretely every, say, 6 months or every 4 months, we see E pop up, which is this Euler's number, 2.7, so on and so forth. That's an irrational number. And again here, since we don't have something happening every n months or something like that, all we need to do is know the rate and how many years we've invested. And this is going to be the formula that we'd use for this. Now, I'll just caution you, even though it feels like, oh, if we're compounding our interest continuously, it sounds like we're going to be earning a lot of money. So let's actually work out a problem to see how much more money we would earn continuously versus, let's say, 4 times a year, every 3 months. So let's say that we invest $10,000 at an annual rate of 8%, and also this question is coming from the math textbook. 8% is a very unrealistic percentage of money in any sort of investing. If you hear 8% when you're investing, you should think that's probably too good to be true. And most things that are too good to be true are simply not true. So we're investing $10,000 at an annual interest rate of 8%. Let's find the balance after 5 years if we compound quarterly versus if we compound continuously. So our P, our principal, the amount that we're investing, is going to be $10,000. Our rate is going to be 8%, and 8% as a decimal is going to be 0.08. We can think 8 out of 100 is 0.08. Our T is going to be 5. It's 5 years. And for our first question, when we compound it quarterly, this means that we're going to compound our interest 4 times a year. This is what quarterly would mean. So let's write down our equation. After 5 years, we'll have A amount, and it's going to be the principal times 1 plus R over N raised to the T times N power. So plugging everything in, this is going to be 10,000 times 1 plus our rate is 0.08. N is 4. And we're going to raise this number to the T times N. So this is going to be 5 times 4 power. And plugging all this into a calculator, which I did off screen, this is going to be 14,859. This is rounded to the nearest dollar, so this is an approximation. So this is our answer to part A. Well, how much money would we have after 5 years if we compound quarterly? $14,859, which is a heck of a lot of interest, because the interest rate is unbelievable at 8%. So this was part A. Part B, we have continuously compounded interest. So here, our formula is going to be our principal times e to the RT. We don't need how many times a year is compounded, because it's compounded continuously, just all the time. And again, when we do this, this will be 10,000 times e to the r times t. So r is going to be 0.08, and t is 5. Let me write this like this, so it's a little bit easier to read. And I did this off screen as well. Just plug this into a calculator, because this is impossible to do by hand. And we get $14,918. So we can see that if you do this continually, rather than every 3 months, you earn an extra, what's that, about $60 after 5 years. So even at an exorbitant annual rate, after 5 years, you only earn about $60 extra on the $10,000 we invested initially. So continuously sounds amazing, and it sounds like you should be earning infinite amount of money. Not quite. This is the way that these formulas work out. Again, both of these are rounded. These numbers won't come out exactly, but yeah, plugging this into a calculator will give us these approximate values.